In today's session, I want to talk about things that can go wrong and how to address those issues. It is a frustrating experience to try some new software for the first time and then to struggle with various errors and warnings that you aren't sure how to address. I want to help you avoid that, so we'll work our way in the session through a series of common types of errors that can occur when you go to run a model update or run a simulation. First off, I want to distinguish between errors and warnings. Errors prevent you from doing something. Whether you are updating a model to compile it, or you are just wanting to run a simulation, they will stop you from what you want to do. Warnings, on the other hand, alert you to a potential issue, but they aren't showstoppers. I'll go to the Preferences option in MATLAB's Home tab. I will then select Simulink from the sidebar and click on the button to open Simulink Preferences. From the left sidebar in the Simulink Preferences, you'll see an option for Diagnostics. Click on that option. As it turns out, you can tell Simulink what to do when it encounters a wide array of issues. From many different circumstances, you can select between error, warning, and do nothing. I recommend that you leave the default settings in place until you are experienced with this and know in your situation which things are critical and which things aren't. At this point, I'm going to just talk through these tabs and point out some of the common issues that may arise. This won't be a comprehensive review of every issue that could occur, but it should give you a good idea of the kinds of modeling issues that Simulink can alert you to, and it should give you a good starting point on addressing these problems. At the top of the Solver's Diagnostic tab, you'll notice the algebraic loop option. You can leave this set to warning or change it to error if you prefer. I don't encounter most of the issues on the rest of this tab very often. If we move on to the Sample Time tab, I'm fine with letting source blocks specify a -1 sample time. A sample time field set to -1 in a constant block, for example, just means that the block will normally inherit its sample time from the logic that is downstream of it, instead of having the sample time set explicitly within the block. The rest of these issues mostly relate to dealing with rate transition blocks and conditionally executed subsystems, like an enabled or triggered subsystem, for example. The Data Validity tab addresses signals at the top, looking at things like data type overflow. This occurs when a data type is forced to handle values above the top of its range. The next section down, Parameters, looks at similar issues such as underflow, in which a data type is forced to handle a value below the bottom of its range. The precision loss diagnostic can be triggered by having a block in your logic that is confined to a selected set of data types, and which creates a loss of precision because it uses a less precise data type internally than the data type of the data that you are feeding into this. I've seen this happen before with a few custom Simulink blocks. The memory section does things like making sure that your memory stores are uniquely named and that you've written a value to memory before you try to read it in. The diagnostic near the bottom about the merge block is letting you know if multiple signals are feeding the merge block simultaneously. If you think back to the lesson in which we looked at using an if-else statement and employed a merge block, you may remember that we only wanted to have one state in our if-else logic active at a time. So it makes sense that the merge block fed by the outputs of this logic should receive only one active signal at a time. The Type Conversion tab handles things like 32-bit to single conversions. This can be an issue because although the single data type is a 32-bit data type, it has a resolution that may be greater than that of, say, minute 32, depending on the value that is using this data type. This is a function of the fact that the single data type has a varying precision. The Fixed Point Constants section down below handles issues like underflow and overflow that are similar to what we saw on the Data Validity tab, but this time for fixed point data types, which are normally custom data types that you set up. We discussed fixed point data types in one of the earlier lessons. Precision loss can occur when going from a single data type, which has a lot of resolution for a typical value, to a fixed point data type, which may have a resolution down to only, for example, the nearest 0.25. So if you are converting a signal with a value of 3.17 into a fixed point data type with a resolution of 0.25, perhaps because part of your logic needs a high level of precision and part of your logic doesn't, and will run on an embedded system and has been given smaller data types to save space, then you may end up with a value of 3.25, resulting in a precision loss of 0.08. This diagnostic can be set up to make you aware of that precision loss in case it will be a concern for you. The Connectivity tab will alert you to certain disconnected model elements, as well as warning you about things like trying to use mux blocks to create buses. I think this behavior was allowed in some older versions of Simulink, but it has been blocked for at least a few years now. There's also a warning that alerts you when a bus block is getting a different set of name signals than the one that it was told to expect. I see this on occasion when an interface changes and I haven't updated the model throughout to reflect the interface change. I think that most of you aren't likely to see either of the issues raised in the compatibility tab, and the issues in the model referencing tab are disabled by default unless critical, so I'll move on to the saving tab. This tab lets you know that there is an issue before you save a model and hopes that next time you open a model, you won't open it to a mess of broken library links to library blocks that can't be found. The Stateflow tab is the last tab. We haven't discussed Stateflow yet, but the diagnostic that I most often see is the warning at the top of this tab, letting me know that I have unused parameters in my Stateflow chart. When this happens, I go to my Stateflow chart and remove whatever leftover parameters are flagged. Simulink can alert you to additional issues as well, things like discrete time and continuous time mixing of blocks, capitalization errors when accessing object fields, undefined or incorrectly defined parameters, errors from missing rate transitions between logic running at different rates, I think size mismatches with constants and arrays, and many other issues. Ultimately, these diagnostics help you address issues in your model and give you a broad range of control over which issues to flag and how to respond to those issues. I hope that you don't encounter issues very often when you are working with Simulink, but when you do encounter a warning or error, I hope that this lesson will be a helpful resource for you as you correct the issue. The one topic in the diagnostics that I haven't focused on yet is Stateflow, but fortunately, in the next lesson, you will learn to use Stateflow.